This conference will now be recorded.
Hello everyone, welcome to the session. Welcome to the AI and ML Practitioner Training Program. So technically this is the day one that we are starting, right? Our journey to learn and expertise on the AI and ML technology stack, right? And before I get into the presentation mode, so I think the meeting link is same what we have used for the demonstration day and even yesterday as well as part of the question and answers session. So the meeting link is going to be changed start from tomorrow, right? So the new link will be published usually in the WhatsApp group that you guys are already joined. If you are not part of the WhatsApp group of this batch, please do contact with the admin team because most of the updates will be flowing through the WhatsApp group, including the meeting link changes, if any, right? So I think by now the recordings and the videos are already been set up in the Valaxy portal. So if any one of you are not having an access to those, please do reach out to the admin and get the access done, guys. Every session will be get uploaded to the same session. I mean to say uh, same course as in the list format. You should be able to see them, right? Looks good. Yeah, once again, thanks for joining and thanks for your time. If any questions, you can unmute yourself and can ask me and can put it in the chat window as well. I'll be actively monitoring the chat window throughout the session, guys. So the ultimate goal that we have is to learn the concepts. So uh, I'm not going through the hard and strict rules. I'm flexible. So usually there will be, a certain syllabus that needs to be covered on a daily basis, right? So I don't have that kind of the strict rules. So I'm flexible. Yeah. Let me get into the discussion for today. I know most of you are um, waiting for the day one, right? To hear from me what is this AI and ML, how the journey will look like, right? I'll get started with that without further delay, right? And as I already told in my previous lecture, right, Python is definitely a mandatory skill before we actually get into the AI and ML related development and even for the deployments, right? So that's the reason our journey will start with the Python. That's where I start with the Python basics, Python introduction, right? And then we'll deep dive into the Python programming skills. So as of now, the estimation is for at least 10 days, we will be focusing only on the Python syntax, guys, because most of you might be pretty new to the Python. I have to ensure that I have covered all the Python basics and you are up to date with the Python syntax. Then only I can get into the ML side of module discussions, right? But obviously, right, if I start with the Python from the day one today, right, you may feel that this is a Python course, correct? Because you are all here to learn AI and ML. Of course, you need to wait for at least 10 days of time to get into the AI and ML mode to start learning what this technology is about and how the use cases will be there, right? So I don't want you guys keep waiting for 10 days of time to know at least some basics of this. And also there are many folks here who are waiting to see what this ML and AI is actually. So being said that, it's better to understand the AI and ML at least from the use case perspective, some high level. Then we'll start with the Python journey right from tomorrow. Okay, that's the strategy that I have, guys. So I have prepared a couple of slides for today discussion, the context that I wanted to discuss for today. Let me go through that, and hopefully you will be liking and getting some general view of what this AI and ML, right? So being said that, without further delay, let me go on to my next slide, right? So basically the AI is the artificial intelligence, right? As you know, the term. So the goal here is how can we uh, train the machines so that the machines will start thinking as like a humans, right? So how a human brain works, right? Usually a human brain can learn something, and with the learnings that they have, with the experience that the human has, right, can take a decisions, right, for any upcoming incidents or the real-time incidents, whatever comes in, correct? So you have learned something, and obviously, right, any real-time incident that are coming in future, right, may not be the same what you have been learned, right? In the past, you learned something. In future, something else is happening, but still you are getting some common sense to apply based on the learnings that you have got, based on the trainings that you have got, and take some, the decisions what can be done, what makes sense for that situation, right? So that is what the human brain has, that capability. So here we are trying to put the same uh, caliber to the machines. How that's possible? That is where artificially we are trying to give some intelligence to the machines as well. That is where all the AI has come into the picture. I don't want to go to the history of the AI and where it is begin, all these things, not needed as well for us much, right? But just one liner word, right? So the AI, like the thought that is it possible to train the machines and add a intelligence to the machines, right? So the thought is happened around 1950s or even before. So it's almost 70 years that it took, right, for us to reach, and it became as a usable product for the people, and where the like it came a buzzword now, right? But it has all happened very long years back, where the research has happened, and this is how it is happened, guys, right? Well, so when we say that we are trying to put a human intelligence to the machines artificially, right? Once we give this intelligence to the machines, right, what the machines can do, correct? Ultimately, we are trying to make use of these machines to do certain useful tasks that the humans can benefit out of it, correct? That's what the ideal goal, why we are trying to train the machines and make the machines our intelligence, right? uh, uh, in that era, right, usually the AI systems, I mean to say the artificial intelligence can be benefited on the robotic side, right? So the autonomous vehicles that you see these days, right, are actually built with the AI intelligence. That's where most of the self-driven cars and the robots, the domestic robots, lot many, right, are actually working with the intelligence of the AI, and the computer vision and the machine learning and the natural language processing NLP. These are the four top subsets within the AI, and these are from the use case perspective, correct? I'm saying that these are the four different application or the use case perspective where the AI can be useful for the humans to get more benefited out of it, right? So just to go in little more details, just high level, right? In the robotics section, there are a lot of self-driving cars are coming these days, and there are many delivery robots are coming in, where the robot itself can come and deliver a product to your doorstep. We don't need a delivery boys, right? So that's where the artificial, you are trying to inject a human intelligence to the machines, and the machines can work as like a humans, right? That's where the things happening, right? And the domestic robots, that's where you can see a lot of vacuums that are in home are able to clean your house. We don't need a human, right? So that's where it is. And when it comes to the computer vision, like the images and the videos, right? How usually a human can learn something by watching a video or by seeing a image. Similarly, if I show a video, I mean to say, if I give a video to my machine, if I give a image to my machine, the machines can also can understand this content and can learn out of it and can help us in a different use cases, right? So that's where you can see these days the usable products, the facial recognition, right? Where you can see it is available in your mobiles, right? And as I said, the self-driving cars, that's where the system can automatically detect the lanes and the car can go within the lane by following the traffic rules. How that's happening without a driver, right? So that's where the artificial intelligence is added, and uh, we are just trying to understand the different vectors where and all the AI is being used. Inside that AI, the machine learning is one more component, right? So where we use these machines from the predictions and the recommendation systems, like stock predictions. These days there are many apps that you see which will be predicting what could be the stock price tomorrow, right? And the humans are following these days by by buying those type of apps and get some predictions and invest there, right? And you see some Netflix suggestions as well, right? So you go to the Netflix, you will see some recommendations somewhere saying that this is the video that is recommended for you, right? For us, it is just a single recommendation, whether you watch it or you click on ignore, or you even say that don't show these type of recommendations. There is a flexibility for the end user how you can use the product, right? So someone say that yes, I like this recommendation, please show me more. Someone say that don't show me. Someone say that no, these are not relevant for me. Whatever the feedback that you wanted to, you can, but in the back end it is actually the machine learning capable systems that can learn the user feedback and play around, right? Let's say if you are liking the video, the machines can learn it. Okay, you are the person who are liking these type of videos. Let me show you more related to that. The next day onwards, you will be started seeing more videos related to the liked videos that you have done previously. That means the machines are learning the user behavior and trying to give you the more based on the personal customization, right? That's where the businesses are getting more benefited because they are trying to improve their sales by enriching the user's experience, right? At the end of the day, for any business, the user experience is matter, and that user experience we are trying to enrich by implementing AI to the existing technologies. So if you closely watch the any product that you are seeing today in your day-to-day world, right? So the AI is just enabled on your existing products. AI is by itself is not a complete new product, guys. AI is not by itself is a new product. No, the AI is injected into your existing products and it is just enriching the user experience, the user, the recommendations, and that's where the the customer satisfaction is little improved, and the the business is scaled up compared to their existing how it was before. Right? So yeah, so that's where it is. You can see the natural language processing. That's where the text and the voice. These days, a human can interact with the machines by talking to them, right? By sending a text to them, right? That's where you can see a lot of chatbots and the other voice assistant systems are came into the picture. Probably the Alexa is one example that I can say, right? So the reason for this slide, right, you should understand what the AI is mean, right, and what are the different primary verticals that the AI applications are being used. And when you learn the AI technology, right, you will get the base of the AI, what it is, how the AI product will be developed. Of course, the technology will be very behind the screen, right, and in our discussions, yes, we'll be learning the AI. What is mean by AI here? Again, are we learning the use cases related to robotics, related to computer vision, or related to natural language processing? What kind of the real-time problem that we are solving by learning AI? That's what is important, right? And we can't learn all of the the verticals, all of the use cases, whatever are built with the AI technology, right? It will be vast as well. So we are learning what are the different vectors, and from the I mean to say, we are knowing what are the different verticals that the AI is being played around in the market, and from the technical perspective, we are limited to learn a certain specific area. That is what is important, which is machine learning here, right? So within the machine learning, we are here to learn how the predicted prediction systems will be working, how the recommendation systems are working, and how the image processing will be working, how the text generation is working. That is what few things that we are trying to focus, which are basically the mandatory things that every AI and ML engineer must be knowing. Right? Whatever I am highlighting, that is what I am trying to focus, and we'll be learning that. So the next slide, again, the same thing that I have shown you some time back, but with a little more information, right? So the case study and the use cases, and what are the tech stack, the technical concepts that we need to implement that. So when you look into the recommendation systems, right, as of today, when you are doing a shopping, right, online shopping portal, usually you see that some products will be recommended. The recommendation products will dynamically be changing based on the user's purchase history, user's behavior, user's personal profile, the time that you are accessing the portal, and it will be keep changing, right? And that's where the user experience will be enriched, and the product sales also will be go higher, because it is trying to give the closest match to the user what the user can purchase, rather the static recommendation that how the people were doing uh, years ago when the machine learning was not there. I mean to say, if you compare the online shopping portals as of today and how it was 10 years ago, let's say just a general example, 10 years ago, the software developer writing the code saying that, hey, please show this product as a recommended product at the time of the user is trying to purchase. That is a static in the sense, every time when you log into the portal, you will see the same product as a recommended product. That's where it is static, because the code is written such that these are the products that needs to be shown. Because the software engineering by default does not have any intelligence. It is just a code. The code will be get executed whatever it is written. The predefined logic is added in the software engineering, and that predefined logic will be executed, will be shown to you. That's it. It can't take a decision based on the dynamic behavior of the user interaction, right? That's where the software engineering world was there before. Now the machine learning engineering came in. Was the difference between software engineering and the machine learning engineering, right? We'll come to that. But before that, you see the same examples that I talked about some time back are just detailed explained here. And whatever the highlight color that you see, those are the case studies that I wanted to go deeper and deeper in our course to implement it. Just to highlight at a quick view, we are going to see how the prediction based systems will be working, and probably I'll take a loan based approval application. Then we'll talk about how to develop it, how the AI systems will be predicting that, and all these things. And uh, this is the high level technical stack that we will be using to develop and implement this loan-based approval system, the scikit-learn, MLflow, Streamlit, Fast API, right? All these things. And we'll see the chatbots as well, where it will be used for customer-based assistance. And there is Hugging Face transformers, LangChain will be used. And we'll see how the semantic search will be implemented, right? Uh, Again, if you observe the trend, right, maybe a years back, when you are searching something in the Google, right, mostly the search will be exact meaning, sorry, search by the exact word, right? Whatever the word that you search, it will look for the same word in their database and it will show you the results, right? So, but now the semantic search is got more popular just because of the artificial intelligence is added to the systems. Is mean that the search can be by a meaning. When you search for a specific word, it won't look for the same word, right? It works for the synonyms. It works for the meaning of the sentence, and it will show you the corresponding results, whichever is closest meaning. So the effectiveness of the search will be more when it comes to the AI-enabled search engines compared to the existing one. As I said already, that the AI and ML is not giving a new product for you. Rather, it is enriching the user experience by adding some intelligence to your existing products, whatever you are using on top of your software engineering world, right? So we can see the pinecone vector database, streamlit, sentence transformers. These are the stuff that we'll be using as part of this implementation. And we'll see some of the email filter projects as well. That's where we can see the scikit-learn, spaCy, all these things, NLTK for tokenization embeddings. And we'll see the text generation as well, the GenAI related concepts, and we'll use the GPT models there to work with, along with the tokenization, embeddings, vector databases, transformers. We'll talk about all these things as well, guys. Just I'm trying to set some agenda for you guys to know what is that we are learning here, right? Uh, um, Now, coming to the software engineering versus machine learning engineering, right? Let's say I have taken one simple shopping portal app here just to describe at a high level, right? Not to uh, not to make it complicated and not to make you guys are confused. So just uh, take a simple example, right? So there's a Walmart application here where you can just go to the online shopping portal and register a account and you wanted to do a shopping there, right? So for let's say without AI, let's say there is no intelligence added to this system, right? Without intelligence added, then obviously whatever the code was written by the software engineer, the code will be executed in the backend behind the screen, and how the code was written accordingly the web page will be displayed and you go and purchase a product. That's it. Basically your system, your website or your app doesn't know about your user experience, right? Anyone who are logged into the system, basically it play the same role because the code is static. What was written by the software engineer, you will be getting the same thing, right? So usually these apps are being developed by the front-end applications like AngularJS, React.js, right? These are the two popular front-end applications that the software engineers are using to develop the uh, a nice graphical interface to the user where the user can go and access these pages, right? But these front-end apps are not logic specific, right? So that's where usually the Java or any other programming languages are there. These Java programs are for backend applications. Is mean that the actual compute or the logic will be executed by these Java backend programs, right? Which we usually call as a REST APIs, right? So when the customer is going to this website and browse the website and wanted to purchase a product, this nice UI is came through this Angular, and it actually connected to the backend like Java programs, Java APIs, or we can say Java application, right? To get this logic will be implemented. When I say logic, right? Let's say when you are trying to logging into the web portal, somehow somehow it has to validate your credentials, right? Are you really passing the right credentials or not? Who will do that validation? That is what is called as a logic. The logic will be done by the backend software program, right? And the software program will be connected to any one of the database, correct? And that is where your actual credentials or any data will be stored, and this software program will be picking the data from there and do some business logic comparison there and give the response back, and that is what you can see the response there. I'm just giving the traditional software engineering world, guys, right? The front end, back end, and the database at a high level. Mostly you all know about this, right? How the software developer will be working, how the software engineering is working, connecting the different components and give a nice use case to the end user and solving certain problems. And in this software engineering world, there is no intelligence is added. That's what we need to understand here. That means whatever the code is written, it just work like this, irrespective of the user behavior, right? So now I wanted to add a intelligence to this portal, right? I wanted to add a human intelligence to this online shopping app. What does it mean by? Probably I wanted to show you a dynamic recommendations to the user based on the user's profile, right? So the different user will be getting a different recommendations, dynamically changing, and even these days the price of the product also will be changing dynamically based on the demand and supply. Who is changing the price, right? We don't need to change the price manually going and telling to my software. The AI, in the sense, the intelligence, we are adding the intelligence, right? That means rather taking a decision of the price of the product by the human, right? My system can take a decision what could be the price of my product, because now it has the intelligence to take a decisions. That's where we are trying to inject the intelligence to this existing apps. That's where the AI or ML is coming into the picture, right? So recommendation systems take the price decisions, right? And get the feedback from the user, analyze the feedback, take a decision, apply it. It do everything, right? So in order to add a intelligence to this existing app, that is where we need a machine learning application, right? If you see here, I have the ML model, right? The machine learning model. So model is a new terminology for you guys, I'm sure. But think of like as of today, model is mean that application, nothing much. You already know what is mean by application, right? App or maybe API. The machine learning model also one application written in code. Some code is written, right? And that code I'm calling as a model, just a different terminology, nothing much. Think of like how the Java program is there. Similarly, I have one Python program. That's it. But this Python program I'm calling as a model. It has its own terminology, nothing much, right? So I have a Python program which I'm calling as a model now. This model now has that intelligence to take some decisions because we have developed in that way, right? So whenever the front end, whenever the customer is trying to access this website, the request will be hit to the front end and it is connecting to the backend software. This software will now be connecting to this machine learning application to get that intelligence. Let's say if I have to show some dynamic recommendations to the user in this website, from where it get the dynamic recommendations, right? My software program is connecting to this machine learning application, and hey, can you give me some recommendations that I can show to my user, right? So because my machine learning application written in Python in this case, right, has the intelligence, it can look after the profile. Basically, it look for the details, right? Okay, who logged in, what is the user profile, what he purchased recently, what he like, what he dislike. He look into all these factors, certain factors, and then it takes some decision. Okay, probably this is the right product for him. Then that recommended product will be given as a response back to my software program, and whatever it get, right, that will be given back to the front end, and it will be shown to the front end guys, to the user. Here the Java program is still there. That is the software engineering world where the software developer is writing that Java program, the backend business logic. Right now, when you are adding the intelligence, these machine learning applications are being developed by the machine learning engineers. So now, if you ask me what is the difference, the software engineering still there, which will be uh, developing certain use cases to the users, and to those software use cases, software engineering developed use cases, to add a intelligence to make them AI enabled, we need a machine learning engineering. The machine learning engineering is the role where they will be working to integrate certain tools, frameworks which are needed to develop a machine learning application which has some intelligence to solve a certain business problems. And my software programs are actually connecting to the machine learning applications to get that intelligence and see how we can serve this use case to the end users. That's how the software engineering and the machine learning engineering both are actually tightly connected to make a final product from the user perspective. When I say that I have the machine learning model, right, I have the machine learning application which has some intelligence to take some nice decisions. How it can take a decision, right? Always think of like this. I'm trying to I'm trying to uh, you know uh, give the human intelligence to the machines, right? With the thought that the machines can think as like a human. That's not my requirement, right? So for a second, forget about the machine learning application here. What if a human is there? Let's say I have a human here who wanted to take a decision. What will be the recommended product for my user? Think of like this. Forget about the software. You go to one store, you try to purchase a product. The shopkeeper will be there. The shopkeeper will show you a lot of recommended products for you, right? Hey, saying that, hey, can you look this product? This is a nice product. Can you purchase this product? It will be useful for you. They will do a lot of explanation. They will give some recommendations for you, right? On what basis he will be giving the recommendations? Because he's a human, he can learn the things and he can make a decisions, right? So if the customer is frequently coming to the shop, you know what kind of the person he is, what kind of the products that he is trying to purchase, because he already purchased a lot of products in before. What does it mean? The shopkeeper is trying to look back to the data to review, analyze, learn from it, and apply for the upcoming real-time incident, correct? Let's say there is a guy who is coming to the shop for last 1 year, and today he came again. Most of the times, before he asks for a product, the shopkeeper will give you a product. Probably you came for this type of products, right? You take it. How he is able to recommend it? Because he has learned it from the previous 1 year data in the sense the purchase history of the specific profile, correct? When he came to the shop, what he bought it, right? And what price that he is usually purchasing, all these things. That is what is the data. The human is learning from the data and take a decision for the next upcoming situation. The same thing will happen here as well. So when I'm expecting my machine learning application is making some decisions, obviously it can't take a decision without reviewing the previous history. So that is where we need a data. What I do is I'll prepare a data. I'll give the data to my machine learning application. What kind of the data? Probably I will keep the data like maybe I'll give some 1,000 users information saying that these are the 1,000 users logged into the portals. These are the times, and this is the person name, the age, the gender, the location, right? And what products that they have purchased previously, the purchase history. This is what is mean by the data, right? I will give this data to my machine learning application. Not one single data, maybe thousands of users data. Then I'll ask my machine learning that, hey, please check my data, learn from it, review the data. Then tomorrow, if someone came, you see if you can make some suggestion, dynamically take a decision. As an example, in the given data, let's say, uh, you know, the 50 years of age person came to the shop and he purchased this product. Uh, I'll give this type of data. He will, it will learn it from there. So tomorrow, if any new person came in with the 50 years as age in their profile, the machine learning application will think that, okay, probably this guy may need this product. Why? In the data, it learned like that, and it try to show the same recommendation. I'm just giving some example, right? So when the data is very important for a machine learning application to work as expected, the data will be prepared by a data engineering team. We will not get the data just like that, right? Someone has to work on it. So the data engineering team will be preparing the data and give the data. We will be using that data and train my machine learning application, add some intelligence to that, and let the machine learning applications are capable to take the nice decisions. So here I'm expecting that the ML engineer or the machine learning engineer, right? The machine learning engineer, right, is to write a Python program and make my Python application, which is having some intelligence, right? That's the expectation. The machine learning engineer cannot write a program from scratch just like that, right? It's not so easy as well, right? To make my machines or learn from the data and add some intelligence to that, correct? Think of like this, guys. Training a human itself is very difficult task these days, right? Right? Making someone understandable is very difficult. Then how are we trying to train the machines and expecting the machines are doing the nice job for us, right? So we can't write a program from scratch for sure, right? So the machine learning applications are already built by the research level, right? The machine learning scientist, or maybe I would say AI research scientist, right? Those levels. So those folks are already developed the machine learning applications. They will be keeping those machine learning applications in the specific repository. We call it as a model hub. Model hub is like a single repository store where all these machine learning models are already built, already prepared, everything is ready there, which we call it as a foundational models. These foundational apps are already there, okay? And the machine learning engineer will just take those foundational models which are already prepared and they will just train those models to their specific business need. The models that are already prepared by the scientists and the models that are already developed and kept into the model hubs are in general the foundational level, in the sense they are just ready to train and work for the specific job role. Think of like this. A student who has just completed a graduation, right? Usually he will be prepared all the subjects in their graduation. That means he is now ready to do any job, but he is not expertised in anywhere. Correct? He has all the concepts. His foundational education is done, but he's not expertising anything. He's ready to do anything. Now, when a company hire a person, right, they will train the person and ask them to do a specific job, right? How that person can do, because he has already a foundation and he can learn anything. Similarly here, the base foundational machine learning applications are already developed and kept it for us. The ML engineer, that means we are going to use those existing foundational machine learning applications, just train that with our specific data based on our use case. If my use case is, my expectation is my machine learning application should be able to do some recommendations, maybe you give the recommendation related data and do the training. If your expectation is your machine learning application should be able to scan the medical CT scan image and prepare the outcome of that scanned image, probably you give the data accordingly. Take some medical data, give it to that, it learn from there and start working for you. So as a single line, already the foundational models are already prepared. Everything is there. We are just trying to use selectively, sorry, take them selectively, train based on your business problem and try to see if it work for you. That's it. That is what we are doing as a machine learning engineers. So there are thousands of machine learning models that are, maybe let me use the right terminology, guys. There are thousands of foundational models that are already prepared by the scientist and they kept it ready for you. But which one should I pick up? Let's say if there are thousands of people who are graduated from the engineering, right, with the foundational education, how would we pick the right candidate who can do my specific expertise job? The companies will put some interviews and filter them, select it, right, and fine tune them, right, then train them, then make them ready for their specific business role. Correct? Similarly, if there are thousands of different machine learning applications that are already prepared and kept it for you, which one will be the right fit for my business? Right? Someone maybe wanted to use this for healthcare, someone for robotics, or maybe online shopping portals, retail. So each business sector has a different use case, right? Which one will be the best for me? So usually the data scientist is the job role who will be taking this business data. They do some explore on the data. They come up with the patterns, right? They look back to the data for the past history. They went through these graphs and all. Finally, with their analysis research, they will come up certain list of the ML models may be suitable for the specific business. They do some recommendations. Whatever the data scientist is recommending, whatever they finalize, the patterns, the algorithms, right? So those are the one which we will be using as a ML engineer and will start training them, right? And then start using them for our business. That's how all these different job roles are, connected, having some dependency, guys. Well, so in this slide, my goal is to explain the different job roles that have some dependency with each other, and what is software engineering, what is machine learning engineering, and certain few terminologies. And we are here to learn the ML engineer role. That means we'll be learning how to write a Python program to get a model from the model registries which are already developed by the scientists and train them with our specific data and make them ready for taking the decisions, because we are adding the intelligence to the specific business problems. At nutshell, let me give you one simple example, guys. Let's say here I have my Python code already ready, which is for a simple loan-based application. Let me start this application. Again, so the goal is not, I mean to say, you don't need to understand this code at this time. I just wanted to show you as a product how it will be. We'll be learning how to write this code later.
Sir, you said like we already have multiple ML models pre-built by and we're gonna use it like as a per requirement, right? So generally, who builds this bunch of this models pre-built, sir?
Those foundational models are built by the AI and ML research engineers. Again, they are developers only, but those roles will be on a specific companies. For example, as of today, right, these pre-built models are there are released by whom? I think Microsoft, Google, OpenAI, DeepSeek, right? Like that, only some less than 10 number of companies are there who has actually developed the models and released it to the world. Not every company is developing the models. Only those companies has the jobs who will be developing the model from scratch. All the rest of the companies are using those models that are developed by these named companies and trying to build their use cases.
Okay, I mean the tools which we're gonna use is generally are the pre-built models, but we will be adding data to it for analyzing generally, kind of, right?
Correct. We are trying to make them trained for our specific business problem. The models are already there. So
Okay.
the main thing is which model will be the right fit for us, how to use them, how to uh, solve our business problem. That is what is the ML engineer is doing here.
So Pierre, Zurich here. If I was to kind of relate this to Python, for example, so in Python scripting or programming, we have built, like already existing or pre-built libraries and modules that we can use, so we don't have to build it everything from scratch. So it's kind of similar to that, where we're saying like, okay, we for our use
Correct.
case, what we want to use, we're just going to grab this library or module and use it in our code. Same way we can grab a model and use it for our use case for the LLM that we need or the model training that we need.
Absolutely.
Okay.
Absolutely. Right. I'll show those models list as well in a while. Uh, right. But let's say this is one simple loan application. We got it built using Streamlit, and in the backend I'm using Python, and I'm using the scikit-learn library, right? And I'm using linear regression models, right? So let's say as a user, if I say that, hey, I have one dependent, I'm the graduate, and I'm the self-employed, and this is my annual income, and this is my loan amount that I'm looking for. Basically, I'm trying to apply for the loan, guys. Think of like I went to a bank website and I wanted to apply for the loan, right? So I wanted to clear the loan in 12 months. This is my credit history, right? And this is my total assets that I have as of today, right? And I wanted to apply for the loan. So basically now the machine learning application which is running can review your profile. Okay, with this profile, the loan can be approved or not. The machine learning application can take a dynamic decision and can give you the response back here. What will be the status of your loan right away? We don't need any loan manager who can review your profile and take a decision. No, right? Even if there is the loan manager manual, right, the human, how he take a decision, guys? He look back to his experience, right? Okay, how many people has come to the bank applying for the loan? How many are rejected? How many are approved? What kind of the profiles got approved? That is general common sense that the human manager might have been learned from his experience, and based on that, he will try to take a decision. Of course, he follows certain routes that the company said what to approve, what not to approve, obviously. But the same thing now I'm replacing with a uh, machine which has some intelligence, and it is able to tell you that it is rejected. So as I said, right, if the machines are trying to take a decision here, you see, right, it has taken a decision that your loan is rejected. How it took a decision, on what basis? As I said, always it has to learn from the data. So if I go back here, right, and you see this is how the data will look like. Again, whatever I'm covering today will be going in deeper and deeper more details in upcoming lectures. Today I'm trying to make everything as a single summary kind, so that at least you will understand what this machine learning, right, as a product. That's the reason I'm covering all this at least certain level. So basically this is the data that I'm giving to my machine learning application for it to learn and gain some intelligence. So this data has what, like you see, right, I have almost 4,000 plus number of records. That means I have total 4,000 number of profiles who has applied for the loan and their status. Let's say each row has one candidate information. For example, how many dependents that they have. Is he graduate or non-graduate? What is the education? Sorry, self-employed. How much income they are looking for? The loan amount that they are looking for. It has all the details, and at end you can see that with this profile the loan is approved or not. And you see the second profile, with this information the loan was rejected. With this information the loan was approved. Like that I have given some 4,000 different profiles with the different combinations, and I'll be giving this data to my machine learning application saying that, hey, can you please learn from this data. It learn from this data, it gets some intelligence, and tomorrow if someone is applying for the loan like this, it look back into his learnings. Okay, I learned from my data that this type of profile was approved earlier. Okay, look like it can be approved now also. Let me approve it, or rejected it. Right? That's how it is learning the knowledge from the data that you given, and then it takes the dynamic decisions like a human. The human also doing the same thing, right? Let's say uh, if there is a loan manager who wanted to approve or reject the loan, he usually go back and look for the previous history, what was the decision taken for this type of profiles, right? And based on that he will take the decision for the upcomings. Same thing the machines are doing here. So how are we going to prepare this data? How are we going to give this data? How are we going to write the program? Because it's all coding, right? So how are we going to write the Python program to give the data, prepare the data, train the application, and let it get some intelligence, use the models? That is what we need to learn, guys. That is where Python became a mandatory skill to train the model, get the model, prepare the data set, and no, use it for your business use cases. Right? Now you know what is the importance of the Python and what is the machine learning. So with this, right, you will get some clear understanding and clear mind, so that you can happily get onto the Python introduction start from tomorrow, and we'll get some basics. Once the Python basics are done, we'll come back to this and we'll see how we can start writing this code to make this happen, and see how these type of applications are actually built.
Sir, please can you just go back a little bit and tune it in such a way that we can have an approved loan. So maybe just play on the numbers. Let's see.
This one, right? Probably I can change some values, but I'm not sure if that can be approved or rejected. Maybe I can say I'm just changing different values. Let's say this is a different candidate who is applying for the loan. You see, now it is approved. Why? I just given some bigger assets, good credit score, less loan amount, income is more. Now it is approved. You got me?
Okay, thank you, sir.
Yeah. Good thing. Now, if I just go at high level here,
Hi, when you said that we are connecting the MCP, I mean model to an application, are we using any interface like webhook or anything? Like how are we connecting? Is it like I heard of the term MCP servers, so is
okay.
it through that like?
Okay, since this is the day one, as much as possible, I tried explaining this concept not to keep more technical words because we didn't learn the concepts yet. So when I say connecting, it basically the API connectivity. So anything in the IT is API nowadays, right? So the REST API and the model API. So the Java API or the backend API is connecting to the model using APIs. It's just API call. What is API? How it call? That's what we are going to learn as well. But it is a API call. Right? So if I just come to this website, skykitlearn.org, right? And this is the, I said, right, some foundational models are already there. We can just use them and see if we can build a use case as a ML engineer. So you see here, I have got some linear model, right? Logistic regression model. And you can see here, there are a lot of models here. All these are the different models. See which one will be best fit and use that and prepare a scenario. In my case as well, I think, where is my code? Maybe here. So this is where I started using sklearn concept and importing some models. This is my model and I'm trying to train it and using the data. You see the data.csv, that is the data that I have shown you, right? How to use this data, how to read the data. So this is what you are learning, how to write this code, right? This is what you are going to learn and prepare a machine learning application, guys. These foundation models are already there from different libraries. Scikit is one famous popular one for minimal use cases, and you can see more models come from Hugging Face as well for open APIs. And here you can see many models here. All these are the models. There will be thousands of models will be there. We just need to see which model will be the right fit for our use case, and each model has their documentation, and we can download this and train it and use it. Look like this is the, I just randomly click on it, but look like this is the model which can generate the images, the GenAI models, right? We need to use it and build a use case. That is what the ML engineer will be doing in real time as well. Do you got a clear-cut understanding today what this is all about? How the ML is slowly becoming as a mandatory skill for every engineer? Because think of like this, we are just trying to add the enrichment to the existing products by adding the intelligence. So any product that you see today will definitely be having the AI touch to increase the customer's experience. That's where this is gonna be mandatory skill very soon, guys. And I hope you got some understanding today. Yeah, we have a right to put your comments. Yes, no, maybe, right, or any other feedback that you wanted to give. And this is the today's concept that I wanted to deliver, guys. Just giving some overview of what this AI and all these things. So the next journey is tomorrow. We will be starting with the Python introduction, and once the Python concepts are done, I'll come back to this um machine learning concepts again. Then we'll do some training part and all these things. So the tracker sheet is already updated. So these are the concepts that I covered today, and this is completed. I'm just marking that. And these are the upcoming topics that are lined up. I will be sharing these sheets links in the WhatsApp group after the today's lecture. You can access them. So looking into the question, sorry, in the chart window, is that model can be downloaded locally? Yes, you can download it locally, right? So basically, even downloading the model, using the model, everything through Python, guys. We use Python commands, Python scripts to download them, import them, use them, everything through Python. Nothing like you go to the website like this and click on it and click on download. No, that's not the way how you download. It happens everything through a Python itself. Right? And looking into one more question in the chat window, what and all jobs that I can apply? As I said, like you are eligible to apply for the machine learning engineer role and the machine learning operations role, ML ops as well, because I'll be showing how to develop the applications like this, and I will be showing how to deploy them as well. When I say deployment, some operational perspective. So this is how the MLOps pipelines will be there, where the model that we are building, right, will be get deployed into our Kubernetes platforms as well using the ML frameworks and the tools. So you can apply for ML ops roles as well. A ML engineer and ML ops both will be suitable for you after completing this course. And looking at one more question in the chat window, are all these models are reliable? Can we trust them? And again, that is what the decision come from the data scientist, right? You see, there's a data scientist team who is doing before taking a decision, right? They will validate who developed the model. Is it trusted or not? How many users are using? Is it open source or the paid version? Do we need to pay something to use these models? All these things will come into the picture now, right? Then we'll take a decision which one will be the best fit for us by considering the security, budgeting, licensing, terms and conditions, all this, right? Some models will be selected and we'll be using them to integrate into our products. That's how it works. Are we downloading it from the trusted portals, right? And all these things will come into the picture, guys. Right, and I see one more question. Can you explain briefly the data scientist role? And I think I already given minimal information on the data scientist role, what they do. Basically, they are the guys to work on the statistics numberings, right, and to explore the data patterns, and they will be come up with the technical checklist, right, what can be used for the specific business purpose, because they will be exploring the the data side, the business side, and the models. They'll do all of this research, and finally they will give what can be the best for our business.
Yeah. Here, as an example, we have taken the loan application. Sometimes it got approved and it got rejected, right? So the data which we have given, and it will the same data it will be captured in data.csv, like that. It is model like that.
You mean to say in the real time, how the data will be? Is it in CSV file? Is that the question?
Yes.
Yes, that's true. We can see these like as of in real time, right? Let's say if I'm taking the loan application as an example, the bank, right? The data engineer who is working in the bank, right, will be preparing this data as a CSV format and will be finalizing the data. We will be using it for our training. What the data means, they will collect. This is not a data engineers. The multiple teams again will be there in the backend. So they collect all the customers, uh, like the customers who has applied for the loan, right? They collect all that of data and they will be maintaining the sheet like this, and we will be using it for the training purpose because we need the actual real-time data for training purpose, right? If the data itself is not having the quality, obviously training will be poor and the recommendations will also be same thing, right? So to get a better results, we need a quality data, we need a real exact data. But for the learning purposes, let's say we are learning now, we don't need the real exact bank data, right? For the learning purposes, we need any data, something like this, to understand how the training will be done. So we can easily download these sample data sets from the data set portals as well. There are, there are web portals where you can download the data sets as well. And even you can download it from the Hugging Face as well. Where is that? Right? The Hugging Face also is, you see here, data sets. All these are the different data sets which we can use for learning purposes, and we can download them as well. Let's say I wanted to see how the loan based data will be there in real time. You can just go and download it. You see that the data is in kind of the Excel format here. The gender, married, dependent, education, loan ID, self-employed. These columns may vary based on the bank to bank, right? So we'll get some information like this, and I can download this data and start doing the training for the learning purpose. But in real time, the same data will be the actual real data of their business. Hope I answered your question.
Thank you.
The other question that I see, right, all the data sets will be in CSV? No, not needed, right? Based on the type of the data, right, may not be a CSV. It can come from a CSV, or it can come from as an XML format, a PDF, or maybe an image, or maybe a video. Type of the business that we are handling, right? It may not be a CSV all the cases, no. So the other question that I see, right, can the MLOps be implemented on premises without Kubernetes? Yes, obviously, absolutely possible. We don't need to deploy this ML application in the Kubernetes only. No, we don't need to, right? It is just an application. At the end of the day, you see, right, this is just a Python program, right? Where you wanted to run this program, it's up to you. I can run this program in Kubernetes, or I can run in a physical machines, virtual machine, doesn't matter. You can run it in anywhere. I just shown you the Kubernetes in my slide because Kubernetes is got more popular, right? The people are interested to see how we can deploy into Kubernetes. That is where I got my pipeline created like that, but it can be deployed into any compute platform for that matter. Right? So that's the story for today, guys. If any questions still I can answer, or else we are good for today. We'll regroup tomorrow. And as I said, the link is going to be changed start from tomorrow. The new link will be posted in the WhatsApp group. If you're not part of the group, please do check with the admin and get the details. And I appreciate if you have any feedback as well. Hope you like the today's lecture, the day one. Thank you.